Hey everyone, this video is to help you with subtracting rational expressions when you have unlike denominators. So the first thing that we always want to do whenever we have subtraction with rational expressions, whether it's common denominators or different denominators, is we want to always make sure we change it to an addition problem. So remember, that means to distribute the negative. From there, we're going to treat it like we did in the addition video. We're going to factor the denominator. Remember, you want to leave the numerator alone. That's the last thing that gets factored. To factor the denominator, determine the LCD, the least common denominator. We want to multiply each fraction to get a common denominator. From there, we're going to treat it like an addition problem. We're going to add, and we're going to simplify. And I cannot stress enough, when we simplify, don't forget the excluded values. Remember, your excluded values are values of the variable that would make the new denominator 0. Sorry, that would make the original denominator 0, but not in the new denominator. So first example, we want to figure out, first and foremost, do we need to factor, and then what the LCD is. So since we have monomials in each of the denominators, we don't need to factor. We just want to focus on our LCD. So remember, the first place we look is the coefficients. I have 2 and I have 3. The smallest number that both 2 and 3 go into is going to be 6. From there, I want to focus on my powers of x. So I have an x and I have an x. They're the same, so my LCD has to have an x in it as well, in order for both the 2x and the 3x to divide nicely into it. Now, what we should notice is we have subtraction, so we want to change this to addition, so make it plus a negative 16. And then we ask the question, or like we said, we can always divide. I can take 6x divided by 2x, and I can take 6x divided by 3x to determine what I need to multiply each of these by. And so in the first fraction, 6x divided by 2x is going to give us 3. So both numerator and denominator get multiplied by 3. And in the second fraction, 6x over 3x is going to give us 2. So when I do this, 15 times 3 is going to give me 45 over 6x. And then negative 16 times 2, that's plus negative 32 over 6x. I go ahead and I combine where I can. So 45 and negative 32 is going to give us 13 over 6x. And in this case, nothing eliminates. So this is our final answer. And because nothing has eliminated, we don't have any excluded values. So for the second one, first thing I'm going to do is change it to plus and negative. And then I'm going to figure out what my LCD is. The biggest mistake that I see people make in a problem like this is they see the b plus 3 and the b. And when I say, what is each fraction missing? They say, well, the second one's only missing a plus 3. And they try to just add 3 to it. You can't do this. It has to be factored. So what I typically tell students to do is to, whenever you see x plus or minus a number, b plus or minus a number, whatever your variable is, you need to put parentheses around it because you want to think of that as its own separate thing. You can't just simply add a 3 and expect it to work out. So my denominator on the left has a b plus 3, and my denominator on the right has a b. In order to get common denominators, you're going to be multiplying. You can't add, so these have to be treated like separate things. This means that my fraction on the left has the b plus 3 from the LCD, but it's missing a b. So I multiply by b over b. My fraction on the right has the b, it's missing the b plus 3. So I multiply by b plus 3 over b plus 3. When I do this, I'm going to get b squared over b times b plus 3. Remember, keep the denominator factored. And then plus negative 4b minus 12 over b times b plus 3. Now that I have common denominators, I can go ahead and I can add. So in the numerator, I'm going to have b squared minus 4b minus 12. Denominator, once again, stays the same. Once we're as a single fraction, we want to factor in the numerator and we want to eliminate where we can. So I have a trinomial. You are multiplying to a negative 12. That tells you that your signs are going to be different. Factors that multiply to negative 12 and add to negative 4 are going to be positive 2 and minus 6. All over b times b plus 3. And once again, nothing is going to eliminate here, so this is our final answer. Lastly, I'm going to change to addition by distributing the negative. And I'm also going to factor my denominators so I can figure out what my my LCD should be. So in the denominator 2z plus 8, I can take out a GCF of 2. So I'm left with 2 times z plus 4 plus negative 8 over, I have a GCF of z in the second denominator. So z plus 4. So for determining what my LCD is, I'm looking at coefficients first. This one has a 2. This one doesn't have 1, so it's technically a 1, so that's a 2. I'm going to account for that. I also have a z out in front, which means my LCD also needs a z. And both have a z plus 4. My LCD needs a z plus 4. If I focus on my first fraction, of the LCD, it has the 2 and the z plus 4. That means the only thing that it's missing is the z. So I'm going to multiply by z over z. In my second fraction of the LCD, it has the z and the z plus 4, which means it needs to be multiplied by 2 over 2. When I do this, I'm going to get z squared over 2z times z plus 4. Remember, when you're doing this, you should always get the LCD in every denominator. And then plus negative 16 over 2z times z plus 4. Once I have common denominators, I can combine in the numerator. So z squared plus negative 16 is z squared minus 16 over 2z times z plus 4. And then I factor where I can. You can factor this numerator by the difference of 2 squares. That's because z squared and 16 are both perfect squares, and you have subtraction between them. So remember, 2 sets of parentheses, one with a plus and one with a minus. To get to z squared, I squared z, that's why it comes first. And to get to 16, I square 4, so that's why 4 goes second. All over 2z times z plus 4. Everything's factored, which means now I can go through and I can eliminate. I have a z plus 4 in the numerator and in the denominator. So my final answer is z minus 4 over 2z. You've crossed out z plus 4. You no longer see it in the denominator. That's an excluded value of z cannot equal negative 4.